section 5.2. Now we're going to be talking about the binomial probability distribution. Now we're going to be using the table in the back of the book. It starts on page A11 and it is called Table 3, the binomial probability distribution. Okay? We are going to use this table to find all of our probabilities. We are not going to use the formula. Ew. All right, so let's look at some examples. Of those mountain climbers who attempt Mount McKinley, only 65% reach the summit. And a random sample of 16 mountain climbers who are going to attempt Mount McKinley, what is the probability of each of the following? So we need to get some important information. We know that we have 16 mountain climbers, so we know N is 16. Okay? We also know the probability that a mountain climber reaches the summit is 65%, 0.65. So, conversely, we know then the probability that they're not going to reach the summit, well, if 65% reach the summit, 35% do not reach the summit, so 0.35. Now, we're going to be finding some probabilities, so what we want to do on our binomial probability distribution table, we want to go to where n equals 16. All right, so I'm going to go to page A14, okay? Now, on page A14, we have, you see the n up here and 16. So this section that's in white is where n equals 16. Okay, now across the top, we've got our probabilities. Right now, we're going to be looking under this 0.65, right? The probability they reach the summit. If we're finding probabilities about reaching the summit, we're going to use 0.65. If we're talking about probabilities of not reaching the summit, then we're going to do 0.35. But we're going to be looking specifically underneath 0.65, this one chunk of numbers where n is 16, okay? If you notice, next to the n, there are values of r. 0 successes, 1 success, 2 success. So these probabilities right here, this is the probability of 0 out of 16 reaching the summit, okay? Down here at the bottom is the probability of all 16 reaching the summit. So we're going to use these numbers to find some probabilities. So on part A, we want the probability that all 16 reach the summit. So we want the probability that r equals 16. So all I have to do is come at my n equals 16 down to r equals 16 underneath my 0.65, and right there is my 0.001. That's all I write. And that's it. Okay. At least 12 reach the summit. Well, at least 12 means 12 or more. So this is the probability that r is greater than or equal to 12. So that means we're going to take the probability for r equal to 12 plus the probability of r equals 13 plus the probability r equals 14 plus the probability r equals 15 plus the probability r equals 16. Okay, so we want, under n equals 16, we want the 12, 13, 14, 15, and 16 will reach the summit. So I'm going to come over here. The probability of r equal to 12 is that 0.155, plus the probability that r equals 13 is 0.089, plus the probability r equals 14 is 0.035, plus the probability r equals 15, which is 0.009, plus the probability r equals 16, which is 0.001. Okay, so that's where I got these numbers right out of the table. When we add those up, we get 0.289. All right, let's find the probability that no more than 12 reach the summit. No more than 12 means 12 or less. It cannot be more. So this means I'm going to add up the probability for r equal to 0 plus the probability r equals 1 plus 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 12. Okay, so we're looking at n equals 16 still. We want r 0 to 12. And we're still talking about how many reach the summit. So we're still looking underneath this 0.65. And so I have to add up all of these probabilities from r equal to 0 down to r equals 12. So 0.000 plus 0.000 plus 0.000 plus 0.000, then 0.001 plus 0.005, all the way down to this 0.155. Okay? And that's where I got all of these numbers. Add them up, and we get 0.865. Okay? All right, let's look at most 15 reach the summit. Okay, which means at most means 15 or less. Okay, so we want to add 0 all the way up to 15. Now if we do that, okay, basically I'm adding everything up but the last one. So if I add up all of those probabilities, 0 all the way to 15, we get 0.998. Now this 0.865 that I wrote down here is just the 0 through 12 that we already added, and 13, 14, and 15. Okay, add those up, I get 0.998. Okay. Now, the other way you could do this is all the probabilities from 0 down to the 16, those should add up to be 1. Okay, they don't always exactly because of rounding. So to get the probability of everything except for 16, we can do 1 minus the probability r equals 16. So that probability was 0.001. So if I do 1 minus 0.001, I get 0.999. Now the answers are going to be off just slightly depending on how you work it. And that's only because they rounded to 3 decimal places. Okay? So you need to, it's very important you let me know how you work the problem. Did you add up all of them, or did you do a 1 minus? Okay? All right. At least 7 do not reach the summit. Well, at least 7 means we want 7 or more. So we know we're going to have to add up the probabilities of r equal to 7 all the way up to r equals 16. But this time we're talking about how many do not reach the summit. The probability of not reaching the summit is 0.35. So this time we're going to look, we're still at n equals 16, but this time we're going to look underneath p equal to 0.35. And we need to add up the 7, okay, so starting with 0.152 and add all the way down to the n equals 16, okay? So 7 down to 16. So that's where I got all of these numbers. Okay. When I add those up, I get 0.311. All right, I'm going to stop right here. We'll have a part 2.